Hi, everyone. Let's now cancel opposite factors. Instead of canceling, what might be a better word? What D word? Dividing. How do we divide opposite factors? Now remember, A minus B and B minus A are opposites of one another, all right? And what do we get when we divide opposites? Non-zero opposites. For example, what is 5 divided by -5? It's -1. Likewise, -5 divided by 5 is also -1. 0 over 0 is garbage, any way you look at it, however. Okay, so the quotient of non-zero opposite factors is -1. Keep that in mind. Classic simplification problem. The fraction 9 minus x squared over x minus 3. And there are a couple of key ways you can do this. First of all, you can look at 9 minus x squared and think immediately, I can factor that as a difference of two nice squares. But how would you do that? Careful. To factor it directly, you would have to factor 9 minus x squared as the factor 3 plus x times the factor 3 minus x. Notice the 3's are in the front. Now, if you write x plus 3 instead of 3 plus x, those are equivalent, so that doesn't matter. But you must write 3 minus x and not x minus 3. So you can factor 9 minus x squared like so, with the 3's in front. Now, what can we do with the 3 minus x up here and the x minus 3 down here? We can divide these factors. How is 3 minus x related to x minus 3? They're opposites. And when you divide opposites, what number do you get? For example, what's 5 divided by -5? Or vice versa. You get -1. So I'll put a -1 up here in parentheses, and I'll put a 1 down here. You should indicate what's left when you divide or cancel out. I'd rather say divide than cancel because when you strike these factors, you do have a -1 remaining, which is really key. So I'd rather say dividing than canceling because importantly, we have a -1 still left up here. The 1 down here is more for form. So 3 minus x divided by its opposite will be -1. A couple of comments. First of all, it's good to put parentheses around the -1 because it reminds us that the -1 is a factor of the numerator and not a term. Because if you don't put parentheses here, some students might mistake the top as the quantity 3 plus x all minus 1. Students might make the mistake of thinking that the -1 is an extra term on the top, and you want to avoid that. So the parentheses help you avoid making that mistake. That's one comment. Another comment is the hidden restriction. When we perform this division, the x minus 3 down here is completely zapped. It's completely divided out, which hides the fact that x cannot be 3. Remember, x equals 3 would be illegal up here because then you'd be dividing by 0. Okay, and that restriction gets hidden in this process. So you should write down the restriction. Again, you can wait until the very end. So then you end up with -1 times all this, or the opposite of 3 plus x, with the hidden restriction that x cannot be 3. If you wish, you can distribute the -1. We get -3 minus x, again, with the hidden restriction. So either of these should be acceptable. Either of these will be equivalent to the given expression way up here. In terms of which may be preferable, that may depend on the context, like if this is part of a bigger problem. So to recap, you can factor 9 minus x squared directly as the factor 3 plus x times the factor 3 minus x. Be careful. A lot of students make this mistake here. When you divide opposites, you get -1. There is a hidden restriction. Make sure you note that. Now, what if You look at 9 minus x squared and you go, wait, I don't feel like factoring that. I'd rather factor x squared minus 9. Well, how is 9 minus x squared related to x squared minus 9? That takes us to solution method number 2, if you don't feel like factoring this directly. Well, 9 minus x squared is the opposite of x squared minus 9. So you can rewrite this as this. That's perfectly okay. You can pop out the -1 factor. The -1 is a factor of the top. You can pop it out. And then you're back to factoring x squared minus 9, old school. So we pop out the -1 factor. X squared minus 9 factors, as you expect. The factor x plus 3 times the factor x minus 3. And then you have a perfect match. The x minus 3 factor up here has a twin, an equivalent factor down there, x minus 3. They divide out to 1. Still, it's good to indicate 1's in parentheses on the top and the bottom. And we get the opposite of x plus 3 together with the hidden restriction. 3 is still an illegal value for x down here. If you plug in 3 for x down here, that indicates division by 0, which is illegal. That restriction gets hidden in this division process. So again, we need the hidden restriction. And if we wish, we can distribute in the -1, the opposite of x minus 3, again with the hidden restriction. Notice that these here are equivalent to what we had up in the previous method up here. Here we basically had -3 minus x with the restriction. Here we have the opposite of x minus 3 with the restriction. Of course, these are equivalent, and they're equivalent to these, which are equivalent. We have 4 equivalent expressions. 4 equivalent expressions, including the various statements of the hidden restriction. Okay, next up, I am not punking you. We're going to simplify this, which you could see in calculus. I'm not kidding. I call these monsters. Not a surprise there. But we'll be able to slay them, and they will no longer be monstrous. That's next time, folks. Get that coffee.